Hi everyone, welcome back to our channel. Today we are going to solve this problem. So the given data in the problem is apply current division rule and find the current across 12 ohm resistor, 6 ohm resistor and 8 ohm resistor. But you should solve it only by current division rule. So in order to find it, first initially you have to find out the total current. So how to find the total current is very important. So now let's try to find the total current. So I'm going to reduce the network here. So this is a 48 volts battery, and I can say that resistor 12 ohm, you can see here what is the voltage at this point, 48 volts. What is the voltage at this point, 48 volts. What is the voltage at this point, 48 volts. 0 volts, 0 volts, 0 volts. Voltage is constant. You see the voltage is constant. Okay, so voltage is constant and current is dividing. I can say they are connected in parallel. So voltage is constant and current division occurs, then I can say those three resistors are connected in parallel. This is what the basics, how the resistors connected in parallel. So voltage is 48 is maintained constant and current is getting divided into three segments. I can say these are connected in parallel. The formula for three resistors connected in formula is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if you substitute in the formula, 1 by R equivalent is equal to, what is 1 by R1? R1 value is 12 ohm. What is the R2 value? 1 by 6. What is the value of R3? 1 by 8. If you solve it, then you are going to get R equivalent is equal to 2.66 ohm. Okay, so now this value is 2.66 ohm. How much voltage we have been applied here, which is nothing but 48 volts. We require the current I. So in order to find the current I, the formula for current I is equal to V by R. So current flows from 48 volts and it will try to flows like this and is trying to form an closed path. So I can write down current I equal to high potential. What is the high potential value? 48 volts minus what is the low potential value? 0 volts divided by R value after simplification is 2.66. Then we are going to get the current as a 18 amperes. Okay, so successfully we have been find the first part. The total current of the network is how much now? 18 amperes. Okay, so therefore I is equal to how much now? 18 amperes. Now let's try to write down the formula for current division rule. So the formula for current division rule is current I1 across 12 ohm resistor is equal to, the formula is total current multiplied with opposite resistor, or rather than opposite we'll call it as parallel resistor, where current is required, is a formula, divided by the sum of resistors connected in parallel. Okay, so this is what the formula to calculate. So if you write down parallel, you cannot understand, just write down parallel resistor. Okay, so now as per this I'm going to calculate I1. Okay, so I1 is nothing but this current across which ohm resistor? 12 ohm resistor. Okay, so how to calculate I1 is very important. We are going to reduce the circuit. So in order to apply this current division rule, we have the formula. We need to have only two resistors should be in parallel, should be in parallel. So this is the first note. If you want to apply current division rule, how many resistors should be in parallel? Two should be parallel. But here, how many are in parallel? Three are in parallel. That's why we are going to reduce into an two resistive branch. So this is nothing but 48 volts. I mean, the voltage at this point is 48 volts. And here we need to find out the current I1, where this value is how much? 12 ohm. Okay, so I want a branch. You can see here, now this 6 and 8 are connected in parallel. So I'm going to convert this. I'm going to draw into a single resistor, so where 6 and 8 are connected in parallel. So when two resistors are connected in parallel, the formula is product of resistor 6 into 8 divided by 6 plus 8. If you solve it, this is 3.42 ohms. So now easily you can employ our formula to calculate the current I1. So the current I1 across 12 ohm resistor is equal to total current. So what is the total current? Already we calculated in the problem, 18 amperes. Total current is how much? 18 amperes multiplied with. So opposite branch, rather than you understand like parallel branch where voltage is required. So in this branch, I want the current. What is the branch in parallel to this resistor and what is the resistance value? So this is 3.42 divided by the sum of resistors which are connected in parallel. So what is the sum of two resistors? So first resistor is 12 value, but is another resistor which is connected in parallel, which is 3.42. If you calculate this one, this you are going to get it as 4 amperes. So successfully we solved the first part, which is nothing but 4 amperes is the first current. Similarly, let's try to calculate the current, this current I2. So current I2 across which resistor you require? Across 6 ohm. What is the formula we had already done? Total current. Okay. So the formula is total current. What is the total current? Total current is, so before solving it, let's try to redraw the network. So you have an 48 volts battery and I want the current in this branch. The same branch you draw it as it is. Okay, and here you have 48 volts and this is the current where I2 is there and this is 6. You can see here this 12 and 8 are in parallel. So already 6 ohms is there. For this, you try to draw a one more resistor and see that 12 and 8 are connected in parallel. So when two are connected in parallel, what is the resultant? Product of resistors divided by the sum of resistors, which is 12 into 8 divided by 20. We are going to get it as 4.8 ohms. So this is this value. So we need to find out current I2 across which resistor? 6 ohm. So that is equal to, the formula is total current. What is the total current? Total current is how much? 18 amperes. So 18 amperes multiplied with, so in this branch I want the current. The formula is parallel resistor. Okay. So parallel resistor where current is required. What is the parallel resistor here? This is 4.8 divided by the sum of resistors which are connected in series. This is 6 plus 4.8. Use your calculator and try to calculate. Then you are going to get the current as how much? 8 amperes. So this is the value of I2. Okay. Now let us try to find out the value of I3, which is nothing but across which resistor? 8 ohm resistor. So for this, I'm going to redraw the circuit. So current across 8 ohm is equal to, I'm going to redraw the circuit. So what is the voltage? 48 volts battery, and here I have that resistor, which is nothing but I3. This is nothing but I3, and the value of this resistor is 8 ohm. So here in this branch you need to find out. So but when you see here, uh, 12 and 6 we need to convert into an one single resistor. Is nothing but these two are connected in parallel. So then you are going to get a one single ohm resistor. Okay, so this is single ohm. Then you can write down product of resistance 12 into 6 divided by 12 plus 6. Product of resistance divided by sum of resistor. Okay. So when you do it, 12 into 6 is nothing but 4 ohm. So now try to find I3. I3 across which one? 8 ohm resistor. Total current. What is the total current? Already solved, which is nothing but 18 amperes. 18 amperes. So in this branch, I want the current. What is the branch opposite to this I3, which is nothing but 4 amperes into 4 ohms divided by the sum of resistors which are connected in parallel, which is nothing but 4 plus 8. So that is equal to 6 amperes. So I3 is equal to 6 amperes. So successfully we have find the values of I1, I2 as well as I3. So this is like a bigger problem, no need to worry. So first find I value and use current division rule, find the current across I1, find the current across I2 and find the current across I3. So successfully we had find the concept. Now, whether we are got correct or not, okay. So to cross check, what we are going to do is, so we are going to apply Kirchhoff's current law at the node what have been shown here. What is the entering current? 18 amperes current is entering. So it is leaving. What are the leaving currents? I1, I2, I3 are the leaving currents. I1 plus I2 plus I3. So where I can write down 18 is equal to, what is the value of I1 we calculated? 4 amperes. What is the value of I2 we have been got? 8 amperes. And what is the value of I3 we had got? 6 amperes. If you add, this also will be equal to 18. Then I can say that 18 is equal to 18. 100% what we had done is correct. This is also we call the verification of Kirchhoff's current law. So if Kirchhoff's current law is verified, 100% our answer is correct. There's no need someone to say whether our answer is correct or not. Just by doing the addition, you will get a clarity. KCL and KVLs are verified, automatically everything is verified and answer is 100% correct. So this is how to solve the problem. Hope you had understand. So just by observing the problem, nothing you get. First listen the problem, write down the given question as it is and try to solve of your own. Okay, hope you understand how I solved. So first I will explain for one. So first you have to reduce this network into an single branch. So there's nothing but 1 by R equivalent is equal to like this, and find out R equivalent and find the current as 18 amperes. And how I had applied the current I1 is, so in this branch I require, I can say these two branches are connected in parallel. So I converted that into a single branch, and now we can see here it is very convenient now to apply current division rule. The current I1 is equal to total current 18 into. So here I require the current. What is the parallel branch which is connected in parallel to this one is 3.42 divided by sum of two resistors which are connected in parallel. Same method you employ, then automatically you will get the answer. Hope you understood the problem. So if you feel the content is really useful to you, please give a like, and please share these videos those who are studying the same subject or those who want to become familiar with the subject. And if you have any doubts, let me know in the comment section. At any time if you comment, I will answer within 12 hours. Okay, so if you're watching the channel for the first time, subscribe to my channel, KV Tulasi Ram. So this is a free channel for the development of students and faculty. Thank you for watching. We'll meet in the next video. Yours obediently Ram. Thank you for watching.